So welcome to all. In this video, we will discuss the questions asked from electromagnetic theory from the previous year questions. Okay, the question is an electromagnetic wave incident on a perfect conductor. What will happen? It is entirely reflected, fully transmitted, or partially transmitted. None of these. See, in conductor medium, when the EM wave is incident on this, the wave is completely reflects back because in the conductor medium there is no electric field exists inside the conducting medium. So that's why whatever the wave EM wave is incident on the surface of the conductor, it is completely reflects back. So the answer is entirely reflected. Second question. The characteristic impedance of a lossless transmission line is given by. See, normal transmission line formula is for general transmission line. What is the characteristic impedance formula? Z0 is equal to under root R plus J omega L by G plus J omega C. This is the characteristic impedance formula for general medium. But it is given, it is a lossless transmission line. For lossless transmission line, the condition is R equal to G equal to 0. This is the condition for lossless line. Okay, if you substitute R equal to G equal to 0, then Z0 is becoming 0 plus J omega L by 0 plus J omega C, that equal to J omega L by J omega C. Okay, J omega cancel out. What is left out? Under root L by C. So option D will be the correct answer. Now next question. A lossless line of 50 ohm is transmitted in a load of 100 ohm resistive. The VSWR is what? Right? What is given? Lossless line of 50 ohm. That means Z0 is equal to 50 ohm and the line is terminated with the load of 100 ohm. So that means load impedance is 100 ohm is given. Okay. Now asking what is the VSWR. To find the VSWR, first we need to find what is the reflection coefficient. Gamma is equal to ZL minus Z0 by ZL plus Z0. Okay, this is the relation of reflection coefficient in terms of load impedance and characteristic impedance. So ZL is 100 minus Z0 is 50. So 100 plus 50, which is 50 by 150. So reflection coefficient is 1 by 3. Now what is the VSWR formula? Which is 1 plus mod gamma by 1 minus mod gamma. That means magnitude of the reflection coefficient. So if I substitute 1 plus 1 by 3 by 1 minus 1 by 3. If I do LCM and simplify, 3 plus 1, 4 by 2. Okay, which is 2. So VSWR is 2 by 1. Okay, so in the ratio we can write VSWR as 2:1. So option B will be the correct answer. Right? Now next, which of the following does not exist in waveguide? Right? What is given? The following the field components does not exist in the rectangular waveguide. First option is TE wave, second option is TM wave, third option is TE and TM wave, and fourth option is TEM wave. So normally in rectangular waveguide, so what are the field expressions in terms of wave propagation? So Ex is equal to field Ex is equal to minus gamma by h square dou Ez by dou x plus minus j omega mu by h square dou hz by dou y. This is the Ex component. Similarly, Ey is minus gamma by h square dou Ez by dou y plus j omega mu by h square dou hz by dou x, and hx is j omega epsilon by h square dou ez by dou y minus gamma by h square dou hz by dou x. Similarly, hy is equal to minus j omega epsilon by h square dou ez z by dou x minus gamma by h square dou hz by dou y. Okay. Now, these are the field components in rectangular waveguide in terms of Ez and Sz. If I take TEM wave, right? TEM wave, that means transverse electric and magnetic wave. So that means Ez equal to 0 and Sz equal to 0. Right? Ez equal to 0, Hz equal to 0. So if you substitute Ez and Hz equal to 0, all the field components becoming 0. Because this is 0, this is 0. In all field expressions are in terms of Ez and Sz only. So all field components becoming 0. If I take TE wave, in TE wave transverse electric wave, so Ez equal to 0. If Ez is 0, remaining field components will be there, right? So in each case, Ex will be there, Ey will be there, Hz will be there, Hy also there. Even for TM wave, Hz equal to 0. If I substitute Hz, all the field components are existing. But if I take TEM wave, transverse electric and magnetic wave, if I substitute Ez and Hz equal to 0, all the field components becoming 0. That's why rectangular waveguide or waveguide does not exist the transverse electric and magnetic waves. So option D will be the correct answer. TM waves does not exist in the waveguide. Now next. If the short circuit and open circuit impedance of line are 5 and 20 ohm respectively, the characteristic impedance is given by. See, what is the short circuit impedance? ZSC equal to 5 ohm, ZOC equal to 20 ohm is given. This is the given data. Okay, and asking that find the characteristic impedance. So there is a formula for directly the characteristic impedance is Z0 is equal to under root ZSC into ZOC. So under root 5 into 20, 5 into 20, which is equal to under root 100. Root 100 is nothing but 10 ohm. So characteristic impedance is 10 ohm. So option B will be the correct. Next, the input impedance of short circuit line of length where lambda by 4 less than L less than lambda by 2. So that means the length of the line is in between lambda by 4 to lambda by 2. What will be the short circuited impedance behavior? Whether it is capacitive or inductive or resistive or none of the above. See, normally what is the formula for a short circuited impedance? ZSC equal to J Z0 tan beta L. Okay, this is the formula for short circuited impedance. J Z0 tan beta L. Right. Now, if I take length is equal to lambda by 4. If I take length equal to lambda by 4. So what will happen? ZSC is equal to J Z0 tan beta is the phase constant 2 pi by lambda into lambda by 4. So lambda will cancel out, which is pi by 2. So which is J Z0 tan pi by 2, which becoming infinity because tan pi by 2 is infinity. And if I take L equal to lambda by 2, then ZSC is J Z0 tan 2 pi by lambda into lambda by 2. So lambda, which is J Z0 tan pi. So tan pi value is 0. Okay. So at lambda by 2, the value is 0. At lambda by 4, the value is infinity. So that means if I take any value in between lambda by 4 to lambda by 2, the value is coming from 0 to infinity to 0. Okay. So if I draw this diagram, by seeing the diagram, you can clearly understand that on the x-axis only length of the line and the y-axis short circuited impedance. right? Let length of this lambda by 4, lambda by 2, 3 lambda by 4, and lambda, right? Now let draw a vertical lines. See, if length of the line is in between 0 to pi by 4, in between 0 to pi by 4, it will be from 0 to infinity. Okay, 0 to infinity, because if I substitute L equal to 0, tan 0 is 0. So it starts from 0. So approximately 0. And if you take the value from 0 to lambda by 4, it's from 0 to infinity increases. Right? Now second is lambda by 4 to lambda by 2. In between these two values, if I take, the value will be infinity to 0. So that means from infinity to 0, the value will be coming like this. Okay? And if I take lambda by 2 to 3 lambda by 4, it will be 0 to infinity. It repeats like this. Okay? Now, see, if you take this value in the upper of this reference line, okay, this is the reference line. In this, the values will be positive and below will be the negative. Okay, so positive means the reactance is positive, means what we can know, it is inductive. So reactance is positive means we can say inductance or inductive. Reactance is negative means it is capacitive. Okay, it is capacitive. Now what is asking, what is the short circuited impedance in between lambda by 4 to lambda by 2? The length of the line is in between lambda by 4 to lambda by 2. So the value is ranging from infinity to 0. So which is below the reference line. So you can say it is capacitive. So the answer is option A will be the correct answer. See, this diagram is very important. Based on this diagram only, most of the times they ask in the previous year questions. Okay, either they ask what is the length of the if the length of the line is in between 0 to lambda by 4, or in between lambda by 4 to lambda by 2, or lambda by 2 to 3 lambda by 4, what is the nature of the short circuited impedance. Similarly, we can have the open circuited impedance also. Same diagram we will have, just reverse it will be. Okay, so whenever the question comes, I will explain the open circuit impedance also. Right? Thank you.